lunch lecture. I think it's now number 10, if I'm correct. And we will be looking at, say, adaptation measures, risk reduction alternatives, and presentation will be given by Bettina Koelle from the Red Cross Climate Center and Marija Bočkarjova from the faculty ITC of the University of Twente. Who is going to start? Who of you? Bettina, are you going to start?
Or I'm starting. I'm sharing my slides and I'm starting off.
Yeah, okay.
And, yes, so I'm, let me see. So you should be seeing my presentation mode slides, is that correct?
Yeah. Yeah.
Good. All right, then I will start. Thank you, Kees, for introducing us and for, well, giving this opportunity. This is a nice way to present and to see who is doing what, but also to provide an insights to the course at the University of Vienna. Maybe the presentation is not perfect yet because we had to swap last minute. Well, this will be corrected, and tomorrow, I think, or in the coming days, the final presentation will be available on the website. So for now, I will just, let's stick to the main line and the main concepts, and I hope this will not, even this sort of late notice will not keep us away from the important messages that we want to share and that we have prepared. So without further ado, today's presentation, today's lecture will consist of a number of components. So I will introduce the economic damage. So what is direct and indirect damage, looking at the well, at the hazards, but connecting them to the damages and damage modeling, how that takes place in, well, in economic domain. Also talk about risk reduction, so the options that are there, handling probability, elements at risk, and coping capacity, and how do we make those choices about selecting the right options. We will also present examples from different places around the world on the structural, natural, and social approaches. So that's where Bettina will also come in. And we will conclude for today with some remarks and pressing questions, perhaps, or maybe we can identify the pressing questions together. So at least then you know, and the readings will be, the list of readings will be completed in a short while. So, so I want to actually to start off with, sorry, identifying the natural hazards, and they were already defined in the previous lectures. So I'm just putting it together here just to list them, what we are facing, and we understand that there are very different hazards that are out there. Well, dividing them by the type, like biological and climatological and meteorological, geological, hydrological. So they were discussed in previous lectures, but also understanding about acute sudden events and chronic slow onset hazards. So this all is, of course, of relevance to the topic when we're talking about what is a disaster and what are the damages and impacts of this disaster. And I'm talking today from the economic perspective, mostly. So when I'm when I'm teaching, then I'm also usually asking, like, how would you define a disaster? What are the elements? So what is it that is making a hazard or any adverse event a disaster? So if we put it in 3 keywords, well, usually I would say these are the, so this is a combination of a natural event, adverse event, and the social, the societal, societal sort of system, socioeconomic system, and its vulnerabilities. So, so let's, well, I would take this definition. So it is an interaction between this natural and socioeconomic system. And what is also important here, that when it is a hazard results in a negative impact on a socioeconomic system, what is really important here is that this adverse event is exposing the pre-existing societal and economic vulnerability. So whether visible or not, they will be sort of amplified by a hazard that hits the system. Well, in our understanding in this field, so we're really looking at in particular about socioeconomic damages and systems. So, for example, a bit less on, for example, environmental aspect of it or natural aspect of it. So in particular in socioeconomic systems, the level of so an event rises to a disaster level, really to the highly adverse event when we're dealing with a vulnerable population. So this pre-existing and underlying vulnerabilities are very important in defining what kind of impact will be produced by hazard. So we can look at them from different, to identify the damages. You can use different statistics, different indicators, and most of them are, or three important ones are the amount of damages, like physical damages, amount of people affected, and amount of deaths. So one of the important, so these are major numbers, and of course other indicators are out there as well. But what I find important is to see that when we are looking at the numbers, how a disaster affects a socioeconomic system, that they are not always going hand in hand. So sometimes there is more affected population, huge affected population. Sometimes there are more deaths and or only, for example, prevailing economic damage. So we have to, but all of them, all three of them, and a number of other indicators make it up, make the fuller picture of what is going on, of the impact. So let's, I'll take an example of Asian tsunami of 2004. And at least for me, I was engaged at that time in hazard or in damage modeling, economic modeling of damage impacts in the economic system. And I started in 2002, and people were actually asking me, so why are you actually looking at this bigger hazards, bigger disasters? And it took me kind of quite a number of minutes to explain. But when this disaster hit the world, essentially quite a lot of awareness was instantly created, and we understood that this sort of hazards can take place, and we are prone to them, and we need to think about them, how we deal with them and how we cope with them kind of in advance. How can we prepare to them? So tsunami and Katrina in a succeeding year, they were really the first calls sort of to the, well, with the global population probably, or at least to the developed world that we're prone to them, and these kind of things can happen. So what I want to highlight in this particular slide is that the number of deaths in this, there were, of course, massive damages, but there was quite a massive number of deaths, so amounting to roughly almost to 200,000 people. So it's a huge amount, and that was spread across the broad geographical area. And why am I telling this? What I'm trying to say is that, for example, if we're looking at other statistics, when we look at, for example, deaths from disasters linked to weather, climate, and water extremes in a period of 1970 to 2012, then we don't see this these deaths, for example, in this in this chart. And this is because these statistics were performed not on the disaster basis, but on the country basis. So these issues of like data also like we do not see always the data in a way that would highlight, for example, this particular disaster. So this is something that I wanted to flag. And another one on the global losses caused by natural hazards, 1900 to 2012 again. So quite a number of disasters are peaking. For example, the Katrina and the Koelle earthquake. However, again, the Asian tsunami did not peak that much here, not because the damages were not extensive, but because they were not, in money terms, they were not as high as, for example, damages incurred in developed world or industrialized countries. So here we are talking yet about another kind of dimension of this damages and sort of a bit of dilemma. So how do we understand the extent of disaster? Is this sort of monetization enough? Does it provide us with good information about it or not? So just on a very global, really on a high level data, this is again something that is coming up. And another one, perhaps one of the last, this sort of aggregate statistics on the global level, the natural disasters that inflict the most economic damage. So this can be direct, at least direct, but also perhaps in some cases indirect. And it is broken down by the type of hazard and by the continent. So so here, for example, we see that most of hazard or damages in monetary terms are taking place in America and Asia and some part of it in Europe. However, the huge human losses, for example, but also damages incurred, for example, in Africa, are just not appearing here because there were, in the previous chart I was showing, huge death toll during due to the drought in Africa. So it's not appearing up here. So again, so we have to use different indicators and see, compare them and make sense of them to understand what is a disaster and how to deal with it. So to go kind of a bit of more to the essence of how we economists look at that. So we look at damages and potential damages, and I will just explain in a minute how we define them. But how we look at them is to look at the, for example, at population and the, well, at the assets that are located in vulnerable places and population there. So so we're primarily interested in economic activity, but of course this has to do with the broader social fabric. So this graph shows the world, the natural hazards globally. World Risk Report can be found on the website. They do annually reports on the global risk. And it shows, of course, very clearly that urban areas and cities across the globe are growing. They are still expected to grow, and in particular, very visibly in those places that are very prone to natural hazards. So this is something that would really flag well, the importance to me of understanding and understanding risk and taking adaptive action. So I will return to these examples of urban areas further on in this lecture. So, but well, keep this in mind. Of course, Asian and African cities are growing at an even higher speed than those in America, or North America, or in Europe. So in this way, we accumulate a lot of assets and a lot of population that is being exposed to higher hazard levels. So something else I will also found it very interesting to compare that so the level of hazard, so this produces let me see, this is the population risk, for example, but this also this graph shows the two indicators, two important indicators: the potential damages that are can be incurred by urban areas or cities, major cities in the world, and the protection level that they are kind of enjoying, or the protection level that is being at this in these areas. So for me, this is really like you see this, for example, Rotterdam is one of the best protected cities in the world. So it's the flooding probability is there at about 1 in 10,000 years. So it's very high level of protection, while New York and Bangkok are enjoying the much lower levels of protection, something like 1 in 100 years. So we see that the differences between the different countries and different cities is huge in at least the amount of or the level of protection. This graph also shows the amount of damage. So the bigger the bubble is, the higher the damage as well. We see that the Shanghai, for example, is the biggest in this comparison, but other cities are also may result, or in hazards in the cities may result in really high damages in hundreds of billions of dollars. So this is something to compare and to have a bit of a sort of a feeling. I think this provides a nice feeling about, okay, so what are we talking about in different contexts? And I will kind of come to this to the elements that are of course important in understanding the adaptation and preparedness to risk. So I will. Having said this was a bit of an introduction to today's to the main contents. So what is it actually that we're talking about? So we're talking about economic damage. So what is it? So a lot of attention in previous lectures were given to physical damages, to direct damages, to understanding the risk, the probability, and of course it was already connected, especially in the lecture in the presentation of Tatiana, I think 2 weeks ago, where she was talking about systemic risks, where you already look at the system level where different elements are interconnected. So I will kind of follow up on this. So we'll be talking about economic damage and particularly about indirect damages. So how do we look? Economists look at disaster impacts as direct and indirect, and sometimes we use different terminology. Like also we use the word direct, second order, third order, high order effects. But essentially, this the major distinction between the damages is being direct and indirect. And tangible and intangible, but what does it mean? Direct and indirect. Direct are the ones that are, physical, mostly physical damages, to be very, very kind of basic on this. And indirect are the ones that are incurred in an economic system. And I will explain that in a way that when I show how we model it, so that will become more clear what is what we're talking about. So indirect damages are incurred in the system, an economic system, be it a region or a country or another geographically defined area, where direct damages are leading to damages to the elements of the system or actors that are mostly outside the affected area. And I'll show it in a minute what is that. So what is important here? So I was already trying to say the geographical area. So the definition of this concept is very important. So what is the dimensions that are important to define when we're talking about economic damages and indirect damages is geographic area. For example, are we talking about a megacity and a metropolitan area? Are we talking about sort of a province or regional level within a country? Are we talking about country levels? So this will define how broad and which kind of impacts we are looking for or we're considering. So this definition of geographical area is very important. Time span is important. Are we looking at the consequences and impacts in a post-disaster time span? Is it a month, is it a week, a month, a year, maybe 10 years? And I will also provide examples with that to illustrate how that can, of course, be important. Scale of societal damage, physical disruption, and economic losses. So which sectors do we consider? Which kind of underlying the societal damages, underlying vulnerabilities? For example, what is the extent to which, for example, population is affected in terms of, well, displacement or deaths and so on. So so I will illustrate now in how we model, so that I hope that will also help you understand what exactly we're thinking of when we're saying indirect damages, and how so we approach this. So if we are in economy, we see an economy as a complex interconnected system with a sort of a circular flow. So where different businesses, sectors are interconnected, and one is dependent on the other, one is selling, another is buying, and they're still supplying to the third party. For example, agricultural produce is being produced, and then it's sold to food processing industry. It is further being sold to retailers, and then we as consumers buying the final product. So just to illustrate this, and of course, so this is kind of is a system, and depending on how this system is developed, it can be more complex or more simple system. But anyway, it's a system of flow. So goods are flowing, money flows are also coming in different directions. And when a disaster or a natural hazard imposes a major shock to this system, it disrupts the established balances. And this is very important for us in economists because we are thinking in terms of sort of equilibrium or established balance within a system where everything is running, you know, naturally. So when this is disrupted, then we have to think about, okay, so what is going on next? So these major disturbances are discontinuities, so they're shocks, and therefore they're not fit in the usual pattern of sort of marginal analysis where we say, oh, if something small is changing, then that will be the effect. So we need a sort of different thinking about it. The thinking about it is, I will illustrate it in terms of a Dutch example of flood risk management. Right. So the questions underlying this modeling can be different. So we can think about vulnerabilities, we think about resilient or coping capacity, possibility to adapt or mitigate the hazard. But the modeling is the process of modeling is about the same. So let's turn to the example of the Netherlands, where we have the flood protection system is consisting of different primary, secondary, tertiary dikes, and these are the dike rings, so-called dike rings. So the question is, like, how would a major disaster propagate in the Dutch economy? So that's what we were looking at. Here we're in a number of direct and indirect damages were identified and listed as seen here. Well, direct damages being as capital assets and inventories, business interruption, roads, utility and communication, agricultural land, residences. So we're talking a bit of a different set of maybe direct damages than we've heard in the previous lectures. However, of course, they are very, very much interconnected. And indirect damages are damages to companies outside the flooded area and adjustments in production and consumption patterns outside and within the flooded area. So following this logic, the very simple disaster model looks like is that an economic system which operates normally is affected. So part of the system is flooded. So this would be the map. If we can translate the map into the economy, that would mean that some of the production and consumption capacity is being lost. So how do we translate that? An economy is kind of one of the standard ways to reproduce or to look at the economy is a so-called input-output transactions table or input-output model. So where the transactions within an economy are reflected in this type of table where we have different sectors and we see how many, what are the transactions or what is one sector selling to others and what each of the sectors are buying from the others. So this is a sort of accounting table, but this in a very kind of one side simple way. It's quite a relatively simple way to show. Okay, so what are the interconnections within an economy between the sectors? It can also be on the enterprise level, but usually because it's data consuming, the data is being the tables are being constructed on the sector level. So what else it shows? So it's all the transactions on the sector level between the sectors. What are they buying? What are they selling? But also the consumption side, the final demand. What do we have on the right-hand side is the personal consumption. Of the final consumption of consumers as we are, but also gross private domestic investment, net export of goods and services, because some of the produce is being exported, and government purchases. So there is the consumption side is being split into a number of elements. And to close the loop, the whole system is is paying the employees, is owners and business capital, and paying taxes to the government. So that would be how the sort of spatially explicit economy would look like on a paper. A simple economy with two sectors could, for example, look like following, like this here, where the there are two processing sector, there is final demand or the consumption, and the total output would be the sum of the intersectoral purchases or transactions and the final demand. And that will also be in balance of what they are, so what they're buying and what they're selling. So no much kind of fuss about that. But this is a very simple and very kind of transparent way of looking at the economy and its complexity. So when something happens, so how do we do that? So if something small is happening, we can just run this model and say, well, if a little bit the consumption is decreasing, or the intersectoral transactions are decreasing, so what will be the effect of it on the total output? But when something big is happening, we cannot rely on the existing balances, on the existing relationships within an economy. So imagine so that's what we are doing within a project and a study that I was involved in. So, for example, risk maps or flood simulation was produced for a part of where the North Holland part of the Netherlands was flooded. So of course many simulations can be possible, and you can model all of them. So what the next step in understanding the indirect damages is first understanding what the direct damages are. So the damage module, including the damage functions, was employed to understand what kind of physical damages that would incur, and then these physical damages were translated into our system of sectors. So if physical damages are present in 2 or 3 or 5 sectors, depending on the data that you have at hand, then you can say, well, 10% of agriculture is lost, and 5% of production or processing industry is lost, and so on. So this sort of loss factors can be found or can be extracted from that, and then they would be put into this table in the input-output table to understand how the system altogether is affected. So we need a lot of information and actually a lot of underlying information about the damage, the direct damages, and the risk simulation to be able to have an understanding about the indirect damages. So when we impose such a shock on the system, so only part of the system is impaired. So what we say is just a physical or a graphical representation, is that our initial level of output or well-being or GDP is dropping. And what it means is that it's dropping to a totally different sort of ratios or totally different relationships within an economy. So we're at some other stage of sort of well, not development, but at some other place when we were, and essentially, so here the time aspect is coming, because understanding how we go from this decreased level of output or economic damages, we will probably restore it, so the economy will restore, but we don't know in advance which direction it will go. So the possibilities that the model tells us is that it will probably go from this E1 level of initial disruption to some equilibrium or balanced level of economy, operational level of economy, for example, to E3 or to E2 or E3. So between different actually balances between the different sectors. Or it can go somewhere in between there to E4. So essentially this we can model it in very different ways. And it is unclear how the system works. Of course, this is a very simple recovery model, and I will show you a bit more complex model in a minute where this recovery is being modeled in a more sophisticated way. So, but let's see what do I mean in terms of this recovery and understanding. So the way that so the level at which the economy will recover at some point And again, we need to identify which point of time we mean. Is it like 1 year after a disaster, 5, 10 years? So usually you would look at 1 year period, but let's look at the example of Katrina, and we can follow it already now for quite some years. So it was 2000, I think it was 2004. So in 10 years' time, the recovery, so the initial recovery was slow, but also looking at the 10 years' time period, the city has dropped by 30% in population. So this is a very significant drop, and this also provides a feeling about how big the disaster was and how big it was also even after 10 years after it happened. And there were also big differences in recovery by neighborhood. But the important, the message here I want to say, to cast is that this 30% drop is just immense. And this is still 10 years after the hazard. So we can look at the rebuilding capacity, newly developed areas, but also the some adaptation that took place during this recovery period. So this reflects on how, so where the economy is, sort of this regional economy is heading. And again, we are talking about 10 years period after the disaster. So this huge disaster was having also huge impact on the economy in the long term. So this one is also, this graph is showing that how the population changed. So there was an initial drop of the population of about 50% because of many evacuees, and in 10 years' time, the drop was 30%. So many people returned, but not all of them. So this also shows that this kind of so we should learn, really. This is, I think, illustrates very nicely and in a very kind of profound way how this project of PARATUS that we're engaged now can help us learn from the past to see what kind of repercussions it can have for disasters in the future. So learning from these cases is very important in understanding what were the underlying vulnerabilities. And of course, in the case of New Orleans and Katrina, the underlying vulnerabilities were the racial differences in income, socioeconomic differences in income, and also the recovery that took place mostly was taken by the higher income populations, where actually lower income populations were left behind, and in many cases were not recovered even 10 years after. So this illustrates a lot of important lessons that we can learn from it. So going to a bit of, let me see how much time I still can take. Another is so what I have explained was just a very simple economic modeling, disaster model. Of course, our area, so our domain, the economic hazard modeling, is developing, and there are many models available. Including, so one of the example is that I wanted to show is the indirect flood risk modeling in Rotterdam, in the city of Rotterdam. So here a more sophisticated, advanced economic model was used. So where it's we're not only looking at what is being lost in terms of the sectoral losses, but also how the economy could recover. And this model includes a number of elements that are more kind of accommodating some flexibility within a system, but also looking at the bottlenecks. So this is a much more complicated model. If you want to have a look at that, I would definitely encourage you to do that. So what it says is that when we are really taking a more advanced look, and we looked at the different types of flood hazard in Rotterdam, the different types of floodings, we're having kind of the damages incurred by or expected to occur in particular the indirect damages as a result of the flooding were depending on the type of it. So the more frequent floods, so 100 years, if they could occur there, most of the indirect damages would depend on the speed of recovery. So the faster the economic system would recover and restore itself, restore the links and connections within it, the less or the damage would be incurred, indirect damages. However, if we would go to 1,000 type of flood, the heterogeneity or the economic structure would matter much more. So there would be different types of direct damages leading to different types of indirect damages. And the one in a 10,000 floods would even be affected, so the damages incurred by this flood would be affected by a household and firms ratio of capital ownership. So here even yet another element is at play determining these damages. So we can here I didn't want to show you how to say I cannot provide the full depth of this economic modeling, but I would like to wanted to illustrate that there are many elements that are at play and many elements that can define the reconstruction and with it the amount of indirect damages that are incurred within the whole economic system or in a broader economic system. So links are there, and of course you're welcome to check them out, but you're also welcome to turn to me for any questions you have in this respect. So I would like to, having explained giving a flavor of what economic damage is, and in particular the indirect damage, is I would like to go to the risk reduction measures and actually how. So how can we plan, or how can we identify and select those measures that are fitting for a particular economic system or a particular area? So here many things are at play, and I want to start with a very basic, again, the definition of risk. So when we talk about risk, it's about the hazard and its probability. It's about the elements at risk and the propagation of hazard to incur damages into a system, and its coping capacity or resilience. So the concept or the terminology can differ a little bit, but I think that what is important is to understand those different elements that risk consists of, and of course the preparation or disaster risk management can tackle either of these elements, and that's how measures can be defined. And I will be illustrating this, and Bettina will be also illustrating this in a minute. So, so when we talk about exposure, I think it's also very illustrative to see this sort of global view of the exposure. And this is the exposure, again, from this World Risk Report. It's 2012, I think, and because I didn't have enough time to prepare the more recent one, so I'm using the old slides, but they're still, the principles are still the same in saying how exposure is different across the different continents and different countries. And for example, I will be illustrating this in terms of I'll take Japan and Bangladesh, and of course the Dutch case that we already looked at. So you can see that the exposure in these areas is quite high, also in this on the global level. However, if we look at the susceptibility, which depends on public infrastructure and nutrition, income, and general economic framework. So the ability to impose to incur damage. This is very different in these three countries. So in Japanese and Dutch case, this susceptibility is much lower, while in Bangladesh is still higher. And I will just illustrate this in a minute. And the coping capacity is also very different across different countries. So the combinations of these factors can be very different. And so the coping, the adaptation would also need to look at that and take into consideration. So which factor is most needed to address? So you can look at this at this report and risk map online. So I will just illustrate this. So the case of Bangladesh is, of course, is a well-known one where the floodings are very frequent, and they're both inland and or the riverine flood and coastal flood. Huge. Well, the probability of a hazard is very high, and the coping capacity and the susceptibility or the vulnerability of this populations and the system is very high, low. So the vulnerability is high, and the ability to incur damages is high. And here I thought it's a nice also example as well to show the compounding risks. The risks are that even aggravating the initial or the baseline sort of flooding risk is the issues of humanitarian pressures, poor sanitation, and garbage piling in the waterways. So seemingly unrelated issues, but of course we see that these are very much related issues. Especially the piling of this garbage in the waterways just doesn't allow the water to flow, and it aggravates the effects of the initial flooding. So just to illustrate it further. So in this case, for example, collecting litter and cleaning up would do not only good for the environmental condition and maybe even touristic attraction of the area, but also for the hazard and the probability to incur damage. So this was a case of Bangladesh, and here we go to the case of Japan, where the probability of hazard and multiple hazards actually is very high as well. However, this country is being able to incur quite high damages still, but being able to cope with it also in a good way. So coping capacity is high, and Japan is recovering usually in a very kind of resilient way which was the example of the tsunami in 2011, earthquake and tsunami, also compound event, when the country restored back and was still able to function in a high level, probably almost the pre-disaster level. So one of for example, the resilience, the examples of it is the drop in the nuclear energy production, because the Fukushima nuclear plant was destroyed or damaged, and Japan was able to. So the nuclear energy production dropped from about 30% in the country's energy mix to almost zero, close to zero. This was replaced by oil, not maybe most environmentally friendly way of energy production, but still that kept the country going and kept the economy going. So this is again learning from the past and understanding where the vulnerabilities are and where what are the main components of risk that we need to look at. This is really illustrating that. I'll go to skip that in a way. So so when we are looking at this the disaster risk reduction options, so the important aspects are the understanding of the nature of risks, the nature of risk that is prevailing in a particular context. It's important to understand. So when we are trying to improve or intervene, we need to understand the trade-offs between today's options and interests. So what kind of changes will it impose in the system? So if we are intervening, we are imposing any structural or any other changes, it will have an impact today, but also on our future options. So if we are trying to adjust and the system, this will also affect our future kind of pace of development, the future options. So when we talk about disaster risk reduction options, we need also to understand what are the, all costs and benefits of it, or at least the relevant ones, because these interventions are usually costly and bringing about costs, additional costs, but of course they are bringing also additional benefits. The way to, so first of all, the listing and understanding of this cost and benefit is important, but also the other criteria can be not least important, such as the expert opinion, stakeholder involvement, and stakeholders, different stakeholders, private, public, societal stakeholders. So all of this is also playing a role when looking at this different options. Monetary values involved, but also non-monetary ones. So it's not on. So this is kind of, we're getting in a quite complex situation here, but also spatial interdependencies. If we're protecting one area, this may have an effect on the other areas. For example, in the upstream and downstream of rivers, measures taking upstream have an influence on downstream. So all of this is important. This is really kind of becoming very complex quite soon, quite fast. So I will be. So how do we do this? So there are different ways to look at at which measures are fit for a particular case, for a particular context. One of them is, for example, the layering approach to risk reduction and financing, where, for example, low probability risks are expected or are suggested to impose some structural measures. So risk reduction is more effective. Physical infrastructure, dikes, dunes, barriers are supposed to be most effective there, while as the risk is or the return period is increasing, more financing instruments are becoming more effective, risk financing, insurance schemes, and so on. And because we cannot, trade-offs are involved, and of course the costs, trade-offs of today, trade-offs of tomorrow, and the future. We need to take to see which risks we're taking, which risks we're not. So some of the residual risk will be remaining and it will not be covered. So, and at which level it depends on the context. And I think the case of the Netherlands and, for example, the US is very also illustrative in this. So I will be talking to yeah. So in this case, so which is level is seen to be safe or enough is really depending on the context. For example, the Dutch context is having a very strong history in high protection levels or low, keeping the probability low. So this safety sort of level or is quite high. So we're talking about a threshold of 1 in 1,000 to 1 in 10,000. The return period 1 in 10,000 years, while the American case would have a threshold in 1 in 100. So the levels are very different. And it's also depending on the society and the historical background. So when we are thinking about risk reduction, so we also need to take this into account, the prevailing level of risk. In terms of adaptation options, we should decide also the trade-off is between doing something or not doing something, not acting. How much should we improve, when, at which time? So again, questions are appearing here, and I think this is really kind of very fundamental and very basic, but it illustrates on what is exactly how we should think about this risk reduction options. So let me see. So one of the tools, and well, not surprisingly, and a very well-known tool is a cost-benefit analysis, but also a whole array of other tools is available, like multi-criteria methods and some other ones. But I think the underlying idea is very important. Is understanding what kind of costs and what kind of benefits are related to any risk reduction, to any intervention. So of course, cost-benefit analysis is featuring the monetization of all costs and benefits. But again, other methods can have other, let's say, the principles of how to select the right or the particular measure. I'm taking the examples of UK and the Dutch case, where cost-benefit analysis is formalized as assessment tool. At least the one for the big public projects. Let me see. So what is I think, well, I'm having a whole course on cost-benefit analysis. So again, if you have questions, if you want to know more, so feel free to ask. Here I'm just highlighting just a few important notes or important elements of it. So for example, here the scope of analysis is important. So the cost-benefit analysis can be as simple as you want and as complex as you can make it. So for example, and it depends on the type of the project or in type of intervention. So for private investments, only private costs and benefits are relevant. However, if we're talking about public investments, all costs and benefits to society are relevant. So for a much broader scope of stakeholders, and they should be taken into account, and a different maybe even different discount rate should be used. But we're getting into technical issues again, not irrelevant, but not enough space today for highlighting all of this. So as an example of the Dutch experience, I'm just picking up a project. Oh, wait a minute. A couple of projects, for example, the More Room for the Rivers, a big project on realized, I think it's already finished, about where 35 selected local projects were identified and realized. So what was going on, that in order to decrease the probability of flood, the rivers were given more space in different locations, so that the river flow can be improved and the discharge can be increased. So different measures were taken. So on the very local level, I will just example of one of the towns along the River IJssel, where well, there is a very kind of narrow point of the river, just where at the city. It has experienced floodings not too long ago, and what it does is that it takes a spatial sort of approach to it. It gives more space in breadth, but also in depth. So the deepening the riverbed, but also the increasing the riverbed. Again, the whole kind of great thing, I'd say the whole lecture can be devoted to that, but you can see the difference in this river, this intervention, where definitely much more space is given to the river, and it improves the well, the flooding or the safety levels, but also provides additional function to the local population. For example, a bit more nature, a nice place for recreation and so on. So this is well, I would say, so we're kind of slowly getting into the next point, where we talk about different types of measures that can be taken, that can be structural or nature-based, or a social intervention. So I will illustrate some of them, and I need to leave enough space for Bettina as well. So talking about, again, to finalizing on the cost-benefit analysis, it's not only, so I don't want kind of to see it as a kind of a very purely technical tool, but it's a tool to understand the broad set of sort of broader context of this of intervention or this risk reduction measures, understanding its broader costs, broader benefits, and the types of them. And again, so this can take. This can be very quick scans, quick and dirty back of envelope calculations, and also are the ones using sophisticated tools and sophisticated analysis. So I'm going into the next topic, just transiting sort of in a natural way. Also the weak links across on the coast of the Dutch coast were also addressed. For example, in Katwijk, there a dune was strengthened and heightened, combined with a parking garage, which preserved the sort of the natural look, the aesthetic looks, but also the technical sort of indicators, and combined it with a function of social function in a way. So I would say it was mixed purpose structural solution, but we can it can be discussed, because this sort of solutions are becoming very mixed in terms of technical and natural ones. So a quick scan for the other types of solutions, just as examples, and a few examples of how the cost of potential risk reduction measures can associate with the potential damages. Let me see. So this is, I will just go to the case of, let me see. So I think, well, I'm just going a bit too fast because I'm just trying to make sense of time. In the case of, so let's still go to the Los Angeles example. it's an area that is highly prone to risk, and where it's sort of the city is squeezed between the mountains and the coast. And it's also where a number of rivers are also going into the sea. So high risk level hasn't experienced major disaster. Well, yes, or at least in the past, but is considering risk reduction measures, taking this cost-benefit approach to this and looking at the measures that would be most efficient. What they're considering is actually not a single measure, but a package of measures. And this is also featuring the kind of the recent thinking about this sort of risk reduction, where different types of measures are being taken in a package. For example, installing pump plants, new pumping stations, putting new sort of augmenting port area so that it acts also as a barrier to the city. The beach nourishment and so on. So there's a whole package of different measures that would make sure that the city is enjoying the right protection. So the example of the port nourishment is here's the photos from Rotterdam, where they did augment the port area. Yeah, should it be, well, I would say it's a mixed purpose NBS and structural approach, so natural and structural, taking the advantage of the natural sort of, sorry, natural way of building up this sort of augmented area and having it as a barrier as well. Other quite sort of American way of measures would be, well, the building codes are of course not only American, but the usual, how to say, the most how to say generic way of looking at the ways to protect is also building codes, measures, and land use planning. Well, I think that kind of piling up is quite American, but perhaps also seen in other parts of the world. Well, not the Dutch case, at least, and making the first or the ground floor really prone to water intrusion. So these are sort of part of the structural technical approach. And the beach nourishment, maintaining beaches and dunes would be a more quite a mixed purpose, but nature-based approach, so that that would enhance the strength of the dikes or the dunes, natural dunes, but also will provide the space for tourism and recreation. Another possible solution is, for example, in expanding the wetlands and also in a way to protect the Los Angeles area, so that the wetlands would also act as a barrier for flood and intrusion of water, saltwater intrusion. Wetlands, or actually not well-maintained wetlands, were one of the reasons for Katrina or for floods as a result of a hurricane to incur a lot of damages in case of New Orleans. So here, for example, I think that's very interesting to see that the calculated direct and indirect damages were in an order of above $100 billion for that case. And the post-Katrina refurbished flood protection system, new and refurbished, was about $14 billion. So it's a tenth of the incurred damages, in fact, factual damages. So this provides a kind of a feeling of how effective the risk reduction measures can be related to the damages incurred. I'll have just 1 minute, Bettina, and I'll give it over to you.
I think it's okay. You can continue for a moment.
Yes.
Bettina battery is low, and the time would still be a bit too short to for her to give the full presentation. So
Right.
she would give a brief comment, and her presentation will be combined with the one on the 14th that we plan later. So so you can still take a few more minutes.
This way.
We have questions and answers, Bettina.
Okay, so another one, but we can accommodate that. Thank you, Case. Right, so I will just continue then, and maybe not skipping everything I had. Another example from the US is the Hurricane Sandy, 2012. Incurred damages $28 billion in the New York and in the city of New York and the broader area. Some of proposed measures, like in risk reduction, also incur in illustrating quite a number of options of levies and nourishment of the coastal areas, enhanced protection of around the city, protecting critical infrastructure. Of course, the 3 airports are there. The cost of all different measures, and I'll show a couple of more other ones, are expected to be $5 to $20 billion. So also in this case already, that would be even less than one single event. Installing barriers at different places within this base near the or around the New York City. So multiple options are available. Can be compared again, a very broad, because we are talking about this sort of area. It's a broad area. It's a very important area for economically, but also culturally and politically. So this would incur a really proper and advanced way of thinking about the benefits that such interventions would bring to. And this risk reduction would bring to the city of New York. So one of the projects, the way, although the many options exist and still exist for New York area. So I'm just taking the academic paper. The practice showed that the one that was chosen to be implemented now is this dry line for New York, protecting only the Manhattan, the lower Manhattan, a combination of probably nature-based and a structural solution where the heart of New York is protected, but also creating new areas, recreation, and aesthetically nice areas for the urban population in this place. So again, a multiplicity or a whole array of different measures can be possible. We discussed with Bettina, like, so how should we make it kind of this, bring about this complexity, but also this whole kind of array of possibilities into one presentation. So we decided to have some illustrations of those. Hopefully that was, I could bring this across, and this is the part of Bettina. So I understand I will just skip it for now, as she's not able to present it, and I'm also not the person.
Marija?
Oh, yes.
You can just go to the first slide, and I can maybe just comment very briefly.
Okay, go ahead, please.
Can you still hear me?
Yeah.
All right, perfect. Thank you, Marija. Just a quick comment. I think it was really fascinating to see the sort of the economic perspective, and I just quickly wanted to take 2 minutes to just flag what are some of the humanitarian perspectives, because there's of course a huge overlap when we talk about economic factors. We're also talking about people, and the humanitarian sector really focuses on alleviating human suffering. And I think we heard before, so I won't go into great detail on really looking at forecast, understanding systems, and really seeing where are some thresholds or some triggers that are reached in forecasts that will actually trigger humanitarian action before a disaster has struck. And I think I just wanted to flag this. I think Mark has already referred to it earlier in an earlier lecture, but I really wanted to say when we look at images of, for example, Hurricane Katrina, we realize that the recovery is much, much harder if help wasn't in place. And of course, navigating, moving tents, saving lives is much more, it's much slower and much more energy and resource intense than when the activities are prepared ahead of time. And so we're looking at risk assessment from a humanitarian lens, particularly focusing on the most vulnerable groups and see how they are affected. And I think what we can see here, and this is maybe the only slide I'm going to show, so we can also open the floor for questions. I'm sure there are many. We're looking at more frequent and severe extreme weather events that could mean change in rainfall patterns. It's of course sea level rise with all that comes to it, affecting livelihoods, but also houses and storm surges, looking at extreme temperatures, rising temperatures overall, extreme heat. And really, this will impact on a variety of humanitarian focal areas. The one is, of course, reduced water and food quality and supply, loss of income and property. I think we heard quite a bit about that also in the economic perspective, but also displacement, migration, damage to human health, and of course, loss of lives. We also heard about that. So I just wanted to give a slightly different focal light on what we've just heard, to say that, of course, these disasters are really multi-layered and of course very complex. And so I completely agree with you, Marija. And I think I want to really say it's so crucial that we really understand the complexity and embrace also other disciplines to really help us deal with the complexity, understand what are possible scenarios that might happen, look at the data to see how likely it is that they will occur, and to really explore what can be done to prevent human suffering or maybe also economic losses. And then how can we help a speedy recovery? And I think we are seeing, and this is also, Marija, what we discussed about, we're seeing a great sense of urgency here, because I think we're seeing more hazards causing more damages, and in combination with also conflict, with also issues of health, I think we really see that there are many strands coming together. So the mitigation and risk adaptation options really need to consider the complexity of it. I'll hand over to you, Marija, for the concluding slide, and then maybe we can open the floor for a couple of questions.
Well, thank you so much.
Thank
Well,
you.
it's great that you connected it, at least that we connected those, different aspects, structural, economic, and humanitarian. So all this, well, let's see when you are able to present this, because this is also hugely interesting and very important, especially to the most vulnerable communities across the globe. Let me see. So we're here, yes. Right. So, so concluding remarks, I was just putting it from my side, and Bettina, please feel free to add to that. So, just to sort of to summarize what we have just said all together. So the important considerations when we were talking about risk reduction measures and options are the underlying societal and economic vulnerabilities. So definitely relating to those, or the social fabric of a region, of the society. So we're talking about the economic structure. So is it an industrialized economy? Is it a developing economy, island economy? What kind of infrastructure it has? So all of this will determine the well, the measures that are most effective and most helpful in this area. So also, but also the hazard has to be understood, the hazard and hazard interactions. Is it slow? Is it acute? Once compounding risk. So all of this comes together here, and the understanding of geography of the area and the spatial interdependencies. Urban, rural, mountains, waterways. So anything, or again, what I was mentioning, also upstream, downstream, and many other kind of examples that exist there. So understanding all of this and bringing it together would really help in picking up and understanding which measures, or maybe bundles of measures, would be should be selected and should be chosen. And again, on the methods of choosing the ones, we can also have a whole course in that. So I think I would conclude like this. Is there anything else, Bettina, you wanted to to add?
Maybe I can add one thing that is becoming more and more pertinent and really hard to manage, and I think a challenge to all of us to really wrap our heads around, and that is compound and cascading events are really becoming unbelievably challenging for vulnerable populations, because you have so many really extreme situations, one after another, not allowing enough time for recovery and preparation for the next extreme event. And I think this is really something that I think we need to consider very closely, is the short time that we see now often between different hazards, not just natural hazards, but also, of course, conflict, etc. Really posing a new level of challenge in many areas. So this is maybe something for us to consider going forward, and there's certainly a sense of urgency. Thank you.
Yeah. Right. Thank you so much. Well, I mean, it was great to prepare this presentation, also to talk together, that we're kind of making sense of how we could look at this. So we're also taking about some pressing questions. Maybe this was already what you have mentioned. Let's open the floor to discussions, because we are, well, there are many questions yet to be answered, and maybe some are coming up here now. So cases, over to you.